We have to find the self-inductance of parallel wires where the current is directed in opposite direction with each other. So that is the parallel wires. Now we have to find the self-inductance. For this, we take a point at a distance x from the first wire where we have to calculate the magnetic field. So that is magnetic field at a distance from the first wire x is equal to mu naught I by 2 pi x, and there will be a magnetic field for the second wire, and if this distance is d, total distance, then this distance is d minus x. So due to the second wire, the magnetic field will be mu naught I by 2 pi d minus x, and there will be the positive sign because the direction of each magnetic field is in the same direction, so that is plus there. Okay, now that's equal to, we take mu naught I by 2 pi common. Okay, that's equal to b. Now flux through an elementary area of width dx along the x-axis dx and length unitary, that is length equal to 1 unit, so that will be equal to, that is like here take element area there, that is width dx and length 1. Okay, so the magnetic flux through this area would be equal to b dot area, b into area there, so area here, area is equal to dx into 1. Okay, that is equal to b dx. Now we have to calculate this flux for the total area, that is mu naught. Now we put the value of b there, that is mu naught I by 2 pi this plus 1 minus dy x, that is the value of b into dx. Now we have to calculate the flux for the total area between the two wires, so that is this area. Okay, so we have to integrate over the d phi, so that is total flux, that's equal to phi equal to integral of d phi, that's equal to mu naught I by 2 pi is the constant, and integral of 1 by x minus 1 minus dy x into dx. And the integral of 1 by x is log x, and integral of 1 by d minus x is minus 1 log of d minus x. Now we have to put the limit there of x. You can see that the we have to take this distance for the limit, so this is a radius of the wire, and if that is y equal to 0 axis, then that is equal to y equal to a, and for this length is y equal to d minus a, so we have to put the limit from a to d minus a for this total area. Okay, so we put the limit there, a to d minus a. There is a correction because we take this as y axis, but it's the x axis there, because we take it as x axis, so that is x equal to a to d minus a. Now we can easily put the integral limit, that's equal to mu naught I by 2 pi. After putting the limit, it will be like log of d minus a by a minus of log of a by d minus a. Just put the limit. Okay, and then it's equal to mu naught I by 2 pi log of d minus a, and this minus will be plus if log of d minus a by a. Okay, and there will be a 2 because we add this two logarithm, and thus we get this. and that's equal to mu naught I by pi log of d minus a by a. Okay, that's the total flux. And from this we know that phi is equal to L into I, where L is the self inductance. So from comparing with this we get that L is equal to mu naught by pi log of d minus a by a. Thus we get the self inductance due to parallel wires. Okay.